So there are going to be three types of selection that we can have. We can have directional, disruptive, and stabilizing. And in my opinion, I think it's easier to show you these in picture form than it is to talk about them. So here are the types of selection that we can have. So let's say we're looking at a population of mice, and originally we've got a range in color from white to brown to black, right? And so it's most common to be brown. So you can see this bell curve. Now, if we talk about directional selection, let's say that due to global warming, there's no more snow in that area. So it really does not, it's not good to be white or light because you're going to not blend in with the environment very well because there's no snow to hide in anymore. You could have directional selection happen, and that's where all of a sudden, instead of this original population, now that bell curve has shifted, so it's more common to see the darker colors, right? That would be an example of that. All right. Now, the next type is going to be what's called disruptive selection. And in disruptive selection, what happens is the extremes are favored by the environment, but the middle is not. So you're going to see this kind of bumpy curve like that. An example of that, let's say the whole environment turns only black and white. I'm making this up. And the brown ones are easily selected, right? They're easy for predators to find. And so the extremes are going to be favored by the environment. Okay, now the last type, stabilizing selection, is going to be where the middle is going to be favored by the environment the most. So let's say for some reason brown, the area turns brown, and so the brown ones are going to be the most successful at life. And so what's going to happen is that bell curve is just going to get narrower because you're going to see the intermediates favored more than anything else. So those are the types of selection that you can have as far as natural selection can go. Now, there's another type of selection called sexual selection, and that's where there's natural selection for mating success. And so sometimes it can result in what's called sexual dimorphism. And that's going to be where you can tell the difference between a male and a female just by looking at them, right? So like a peacock, right? You've got a very, very showy peacock male, and then the female is all like frumpy and brown and, you know, nothing to look at, right? That's sexual dimorphism. So a couple of types of selection. You can have intrasexual selection, which is where you've got competition among one sex for mates of the opposite sex. So they're basically going to be fighting off each other to keep a group of females, right? So a single male patrolling a group of females. And then you have intersexual selection, and that's where you've got usually females being choosy, and so you're going to end up with a lot of showiness like a peacock would have. So I've got some pictures, some pretty hilarious ones to show you of these. I just love that. Look at that giraffe giving that kick. So those are males that are trying to fight off each other because they have a little harem of females, right? So that's going to be intrasexual selection. Once again, this is a little bit closer to home. You've got the bighorn sheep, and the males are going to be butting heads, trying to keep the one away from their women. And then intersexual selection is where you have the choosy one, and so they're going to have a lot of showiness to be like, look how good my gene pool is. Isn't this amazing, right? And so they're going to be very, very showy. And then you've got your female peacock, not as showy, right? Hopefully you know why that is, right? So why would the female peacock be so frumpy looking, right? I mean, it's still kind of pretty, but the reason behind that is so that she can actually blend in with nature so she can protect the nest, right? So there is a function for that. So once again, in mallard ducks, you've seen the showiness, right? Where the male is very, very ornate and the female is more designed to blend in with the nest. Okay, now going back to here, one question that people ask is, so we've been doing this for millions and millions and sometimes billions of years, why don't we have this perfect organism that's out there? Well, first of all, selection can only work on what we've got, right? So what we have been evolving from. It can't just come out of nowhere. Evolution on that line is limited by historical constraints, right? It can't change something completely, and maybe it will, you know, in the future, but this is a slow process. Another thing that's an interesting point is that adaptations are often compromises, and what that means is something that might be an advantage in one situation could hurt you in another. Look at the peacock that was all showy and beautiful, right? That's definitely going to be great for finding a female mate, that's going to be awful for finding a predator, right? The predator's like, oh, there you are, and it's going to eat him, right? So you got to think about that. Another good example of this is our hands, right? Our hands are awesome. They're so dexterous. We can do so much with them, but they're very, very delicate, and we can break fingers very easily. But that's the trade-off we make. And then another thing is just chance, right? So we don't know what's really happening, and the environment is always changing and all of that kind of stuff. So this is kind of a dynamic process. So that's going to be how evolution happens. I hope you enjoyed that.